Hello, good morning, or potentially good afternoon or evening, depending on where you are in the world, everyone. This is the June 13th meeting of SIG Apps. I'm going to be hosting. I'm Kenneth Owens. Majak will be co-hosting. I think he might have to dip out a little bit early. And I think Janet couldn't make it this time. So, starting. No real announcements. We have some discussion points. So does someone want to talk about last outstanding conformance test? Matt?
You still seem to be muted, Maciek.
Can you hear me now? For whatever
Yes.
weird reason, it is when I mute myself, I have to switch devices back and forth. Whatever. So Ryan put this into the agenda last time. Philip looked into the test itself over the past couple of days. I already approved it, although Philip pointed out that, first of all, we can't verify the serial testing even manually before submission. And there appears to be a problem with this particular test, that it is actually failing. Philip tested that on his own local cluster. So the test is approved as soon as, and Philip is working on ensuring that we can actually trigger the serial test in a pre-submit, because currently it is not possible. As soon as that gets solved and the test passes, Philip has the rights to merge it. So this should be handled. If I remember correctly, that's one of the last pieces for conformance.
Yeah, I think that's it.
Yeah. Philip, did you want to add something to that one?
Yeah, I think that's complete.
Cool, thank you.
Okay, next would be stateful set slices.
Okay, let me try to present. Everyone, I'm Peter. It looks like screen sharing is disabled for non-hosts.
Yeah. I'm going to make you a co-host temporarily.
Okay.
Can you share? Yeah, there you go.
You seem to have been muted. Okay. I can jump in for Peter then if he can't actually share and talk at the same time. Does that sound good?
Well, he should be able to share and talk at this, and there's like I didn't mute him. He's not muted presently.
When I start sharing, my mute button becomes grayed out and I can't modify. I can't unmute myself. So I think it's a known issue I've seen on other SIG groups.
Oh boy.
But yeah.
Actually, would it be easier if I present then and then?
I think so, yeah.
Okay.
I'll send you the link, Matt.
Yeah, I've got the link. Would you mind making me?
Gotcha.
Thanks, appreciate it.
One second.
No worries.
Okay, Matt, you should be able to share now.
Okay, thank you. And yeah, that's going. I want to share.
Great. Okay. I'm here today to discuss this cap of stateful set slices. I've posted a link to the enhancements repo in the chat. The motivation behind this project is this long-term idea of migrating a stateful set across clusters. So we've discovered some use cases for certain sets of users that may want to move stateful sets out of a cluster boundary, and maybe due to scalability limits, tenant or application isolation. So if you need to, say, move out of a shared cluster to an isolated cluster, or encountering features that are end of life in a particular cluster and are only available on new clusters when they're created. So the goal here is to be able to move a stateful set while it's still hosting an application in piece by piece from cluster A to cluster B. A lot of existing solutions are out there that allow for like a backup of a stateful set to be created or a stateful application to be created, underlying storage to be snapshotted, and then rehydrated in new cluster. Unfortunately, this requires scheduled maintenance and downtime for an application. Next slide, please. So in order to do this, building block, well, there's several building blocks that are required. So moving an application over, you can consider a process of, say, scaling down a stateful set in cluster A and scaling it up in cluster B, and moving pods over, so replicas of the application. In order to do this, though, you need some networking configuration in order for an application in cluster A to talk to a logical application in cluster B. You need some storage orchestration for underlying disks to be moved or disks to be snapshotted if we're moving across zones, for example. And then the final piece is the actual replicas of the application that are being moved. So take, say, a 3 replica database. That's what we're talking about here, moving over those specific instances. So maybe moving secondaries over, performing a failover, and then bringing up a primary on a cluster B. So this cap is just focusing on the third problem here. I know that there's a lot to be solved here for networking and storage, but I'm just focusing on creating a building block that enables this third problem to kind of be solved. So next slide. So the core problem here that can't be solved today with stateful sets, if they're running in a single cluster, is that there's kind of this split brain control problem, where if you have 2 clusters, they have separate control planes. There's no way to really have a logical grouping across the cluster. So in order to run a logical app with worker nodes in both clusters, need a way to be able to have a global view of the resources across the clusters. So either so the approach here really is to kind of split up the stateful set or split up the logical application to have distinct responsibilities for slices of the app to be in different clusters. So kind of the schematic below, there's a stateful set controller running in each cluster, cluster A and cluster B on the left and right side, and pieces of the app running in both clusters. So we could imagine if there's a 3 replica stateful set, pods 0 and 1 in cluster A, and then pod 2 in cluster B, and being able to move pod by pod over across the cluster. You can imagine, if you have more replicas, you can do this faster, you can do it slower, but the idea is having a mechanism to be able to orchestrate pod movement while maintaining application availability. And then next slide, please. I think there's one more here. So the proposed changes in this KEP are to be able to slice a stateful set. So currently, there's only the spec replicas field enables the control for the number of replicas in a stateful set. But the proposed changes here are allowing the user to control both the start ordinal and the end ordinal. So currently, the end ordinal control already exists using the replicas field, proposal here is adding a new field called replica start ordinal, which would enable kind of a start and end ordinal to be defined effectively. So you can imagine, here's kind of an example. So cluster A, you have, say, an app or a stateful set that had 3 replicas, 0, 1, 2. It originally started with replicas of 3. If you wanted to migrate one of those replicas to cluster B and kind of still maintain a logical app, you could do this by using the replica start ordinal field, spinning up a new stateful set in cluster B, adding replicas 1, replica start ordinal 2, and then scaling down replicas in cluster A so that you have the same application replicas across the global view of both clusters. But you're able to split up the stateful set using those fields. So I'm bringing this problem to SIG Apps today to ask for some discussion feedback and some insight into this idea, kind of presenting this as a core problem rather than this is the definitive solution we want to take to kind of solve this problem. And just kind of want to get some feedback for feasibility of this idea, if people have major concerns, if people can think of alternative ways to kind of solve this problem without needing to add this particular API. So I'm going to stop there and just open the floor for discussion.
Well, I want to understand better what you mean by migrating a stateful set across clusters. Do you mean by like another cluster can adopt the storage resources of a previous cluster? Because there's not a lot that you can migrate across clusters that makes a lot of sense. Well, I guess it depends on the scenario, your deployment scenario, right? But
yeah, so there's kind of 2 scenarios in terms of storage that we're thinking of. So one is being able to adopt the storage resources. So say if you're using a persistent disk, or some network attached storage, moving the reference to that storage pointer across clusters would enable that same disk to be detached from the existing machine and then reattached to a new machine on cluster B. So that's kind of the in-zone availability region migration. And then there's, say, cross-regional migration, where you would take a snapshot of the disk, rehydrate it in a different availability zone, and then start consuming it in a different cluster.
So, but I guess the thing here, it would help if you could probably give a more specific example of what you're trying to do in terms of application availability under these constraints, right? Like I'd have to imagine that the client application for this lives outside of either cluster, right? Because you're tearing, or does it like, I don't understand what the networking would look like, I guess. Like if you have some type of, like, let's say you're on AWS and you're using Global Accelerator to ingress across multiple regions like you were talking about, right? Or you're at Google and you're using GFE, whatever. So you have these 2 disparate clusters that are getting hit at the same time, and you're trying to orchestrate migration of the storage along with the networking simultaneously to have it not lose availability, or like what? Because it would seem that like at some point, if your networking is entirely in cluster, as you tear down one, like the other, like it's just hard for me to kind of get a grip around what available means in this context. I kind of get what you're trying to do with the storage orchestration in terms of like, I want to be able to, I guess, recreate, like, how would you, inside of the cluster, how would the volumes be migrated? Like how would you ensure that like the persistent volume claims that are generated by the new stateful set actually adopt a volume that corresponds directly to the volume that you've migrated out of the first cluster, for instance? I
see. Yeah, that makes sense. So let's take a scenario of, say, a 3 replica database that we're moving over, and for ease of like example, let's say it's a primary, secondary. So 1 primary, 2 secondaries. So the orchestration of the storage would kind of be an external component, and that's still something that we're working on prototyping and kind of thinking of, but it would require orchestration of some external system that's unrelated to the specific stateful set KEP that we're discussing. But like one example could be, say, you initiate this process from a stateful set, and you determine which volumes are actually consumed by the stateful set, maybe by an application selector that the user specifies. There would be potentially some agent that would be migrating these references. So recreating persistent volume claims in the new cluster that point to the same underlying storage. So you effectively have copies of the persistent volume claim in cluster B, the one you're migrating to. So they'd really reference the same storage. In the application, once it's turned down in cluster A, it could consume the same storage reference in cluster B.
So would these volumes be like write one, read many, write one, read one type volumes? Like how would this actually work?
These would be RWO, so
read write one.
Read write once, yeah.
So you have to detach it from one. I guess I think the thing that I struggle with is that, like, without the motivating example of the external orchestrator, it's unclear on like what the best thing to do with stateful set is in order to help. And without like some details about the system that would actually migrate the persistent volume claims in a consistent way, like it's hard to reason about the correct behavior of stateful set in this context, because you are talking about probably several orchestrators that will be required in order for this to work effectively, leaving networking out of it, which I don't fully understand. Like, I think if you're looking at replicating across geographic regions or geopolitical boundaries, aside from, instead of just clusters in the same like data center, there might be entirely different constraints there. It's hard to reason about like if this is the right thing without understanding the mechanics of some of those other pieces.
Yeah, I think that's a fair criticism. I think that does make sense in terms of this does fit. This is a building block in a larger story. So I guess the one thing that for networking that we're considering using multi-cluster services. I know this KEP was introduced in 2020, and it's gained some traction kind of. So being able to use that for networking across clusters would enable that to be set up with the application before migration is initiated. But I agree. I think the major unknown here is really the storage orchestration. That's something that hasn't really been proposed or like brought to the community yet.
On the plus side, I do think that the implementation for what you're proposing is fairly straightforward, right? Because all you're saying is give me an extra field that determines the start number of the ordinals for enumeration. And then, like, instead of my replicas starting at, I would go app2, and if I scale up to 3, for instance, and you're on the second screen over here, it would be app2, app3, app4, right? That's basically what your ask is.
Mm-hmm. That's right, yeah.
Yeah, that seems like the KEP has the benefit of, like, I mean, it does seem fairly straightforward. The kind of downside from my perspective is that, like, the motivation's a little bit weak without understanding what the external orchestrators that it would actually be interacting with are, right? Like, because you're at, like, the typical thing we would say is, like, you know, you can always do this work out of tree, you can always fork stateful set, you can always operate with your third-party controller using custom resource definitions and just have a blast, right? Like, there's nothing stopping you from doing that today. If you want to put it as a feature in core Kubernetes, like, inside of a V1 API, it would be helpful in terms of facilitating that, to have some strong motivation in terms of the systems that would actually benefit from making the modification, shepherding it in, and then maintaining it over time.
Got it. That makes sense. Okay. So I guess to kind of reiterate, what I'm hearing is this needs to fit in kind of a larger story. Like, I guess the vision needs to kind of be described with more detail to kind of be able to motivate the addition here.
I mean, that's my 2 cents, but my 2 cents is not exhaustive of the entire Kubernetes community. So, like, I think it's worth offering it. It's just, again, like I'm just giving you my feedback about like, looking at it, what I see is kind of like the strength of it and kind of the weakness of it, which is like the feedback you asked for. The feedback that I'm seeing is like, the feedback that comes to my mind is like, it's really hard for me to wrap my head around like I get what you're trying to say, but like making a change to a V1 API that we're going to support pretty much, because once it goes GA, it's forever. And not having any client systems that would actually be able to leverage that to provide value to the end user is a hard thing to motivate, right? That's kind of the way I see it. And there may be other people like, if you offer the cap, there may be like a bunch of, maybe there are pre-existing systems like, VMware and a lot of the other storage providers have existing systems that will attempt to migrate storage across clusters already. So maybe this integrates well. And maybe the thing you can do is just by offering the KEP to the community, get more motivation and other people saying like, yeah, this would really help, so like that's a starting point that would maybe motivate it. But as it is, like, if you were saying like, hey, I've got this system and I think there are some other systems in the community that would benefit from this feature and it would allow us to actually more reasonably like lower the disruption of doing cluster upgrades, because a lot of Kubernetes providers do encourage effectively blue, green, or red, black for how you should maintain your clusters, right? Like they don't say in-place upgrade is the happy path. They'll tell you roll up a new cluster and then migrate your workloads to it and then turn the old one down. And I totally get that. So like, trying to do things in that space to facilitate that, I think it's worth doing, but it's just hard for me to look at this and say like, okay, so we're going to commit this, take this cat, commit this patch, carry this patch, and I don't have a user for it, right?
Mm-hmm.
Got it. Okay.
Excuse me, could I just click down a bit on your comment before about doing this via a custom controller and CRDs? Because kind of the context we're coming from is like we could envision how like the PVs and PVCs could be managed with a custom controller, but the problem was there isn't anything you can do with a stateful set. Like these stateful set controller as it exists today, is going to try and create a certain set of replicas, and there isn't any sort of flexibility or way to extend or deal with that. So like the only way we could see, doing this without changing stateful set is basically forking the stateful set controller. Anybody who wants to use this, instead of using a stateful set for their workload, would have to use our special stateful set version instead, and and like kind of have a complete fork. So a part of the idea of this KEP is like, how can we do a minimal change to the stateful set to allow these extended usages, but still have as much as possible in external controllers, so we don't have to like boil the ocean and solve like all problems in one KEP. Does that make sense?
It does. I mean, like totally, I get it. You're like, okay, what's the lightest touch I can make for a state? But like, are you planning on implementing something? Is this feature blocking for progress for you guys, or like?
So we're actually in the process of doing a proof of concept of this. I mean, I think the plan we have currently is actually to have a fork stateful set controller. I mean, considering that we want to do our proof of concept in the next few months, like that's kind of the option. And like in parallel, we are proposing this KEP, which is our current plans now. Because we're still in the proof of concept phase, like I feel like there's still quite a bit of scope for changing how we do this, which is the, this is the motivation for starting the discussion on this KEP. But yeah, like in the next couple months, we plan to have a POC of the volume controller out, which I think will maybe help clarify this use case and could help more concrete discussion.
Would the volume controller be open source as well? Would you be contributing that, or?
That is the ultimate plan, yes. But because it's like we don't have to change anything core to do, like currently, at least as we see it, we can do it
purely as a out of tree controller. So we haven't sort of started the upstream process yet until we kind of need to get an implementation and actually test stuff before we start making wild speculations,
Yeah. So I mean, like, again, my gut reaction is the touch is light. Like, you're asking to change the beginning of the ordinal numbers. It doesn't seem like there's not a whole lot of things that would break for current customers. I can figure, like, it can think in my head pretty trivially how to do it in a way that's backward compatible. So releasing it is fine. The main thing is, like, once it's out there, it's out there forever. Like, and if you had like 3 or 4 different use cases where it's like, these are the things it supports, then that would be a strong motivation. You don't have 3 or 4 though. You've got like 1. It's a good use case, right? But like, if you're already like, look, I gotta fork it in order to make this work for my POC, then I'm gonna do the volume controllers and release them. Why not run with that? And then, like, you can keep the cap open to get more community feedback and kind of try to build momentum around what you're trying to do here. And then from there, when you have something that's a little bit more like concrete, we can look at like really have some evidence and some signal to assess, like, okay, this is like the right thing. And then we can look at bringing it in trade.
Yeah.
Does that sound reasonable?
Yeah, absolutely. Yeah, I mean, and for sure, just, I mean, also the reason why we're putting out this here is, we had a few other ideas of how to do this. For like, just as an example, instead of just having a start ordinal, one could do something where you have an arbitrary subset of replicas that the stateful set controller is responsible for. And that would give you the capability of doing something more like a cross-cluster node cordon and drain thing, where, an arbitrary subset of the replicas of the stateful set are being migrated, which would allow you to do a cross-cluster migration in a way that's exactly analogous to a node, cordon, and drain. That seems sort of like overgeneral to us and like a bit of a higher touch thing, but like, yeah, this is something where we certainly wanted to start the conversation in case anyone in the community had more experience or intuition as to, like, how the right way to do this would be.
And to Matt's point, we have encountered some forked implementations of stateful set that do offer this type of API, like mostly just for testing, like TIDV, for example, has forked stateful set to do this. So it seems like there is some use case, at least for, like, testing purposes, that may make this particular API useful.
Yeah. But in general, though, I think your comments are well taken. It is kind of hard to reason about this until you have a more concrete view of what the actual end goal is. So thank you.
One other thing to think about is, in your cap, did you include what the semantics would be for setting the field for an existing stateful set? Or would it be immutable on creation, or like, how would that work? Like, I like the semantics of what it would do if you're actually able to orchestrate the resource transfer across clusters within the same region, or even across regions, right? But in thinking about how orphaning and adoption actually works, like, I could see ways that this could, I mean, yeah, I guess because stateful sets have a unique name anyway, it wouldn't be too bad. Like, you're never going to be in that case. But like, would you expect orphaning behavior, or would you expect deletion behavior? Like, what happens if you set this field if it hasn't been set previously? If that's not in there, you might want to think about adding what the desired behavior is there, because that could get a little bit hairy. But I even don't think that, in terms of a corner case, is particularly like nasty.
Yeah.
Yeah,
I mean,
there's some discussion about what the defaults are, what setting this replica start ordinal would be on an existing stateful set. I agree. There's definitely some edge cases around rolling back to a stateful set controller that does not support this field. It can lead to some unexpected, if the user isn't aware of that behavior, like, it can lead to some application, like, effectively, if you had replica start ordinal that was quite high, say like 3, it would, try to delete pods that are greater than a certain ordinal and then recreate the ones from like 0 to 2. So there would be some like application, like some pod churn that may be unanticipated or unwanted if during rollback.
The fiddler bit is actually with the PVCs and the storage creation, right? The storage provisioning. Because like, especially with a stateful application, your expectation is you're going to get very particular volumes associated with your stateful set, right? And you're going to have data on them. But now with default settings, you're not going to lose that data. It would still be there. You should probably be able to retrieve it by scaling the stateful set up particularly, but associating the exact volume with the exact pod that has the identity you want, it is going to be fiddly if you roll back, right? Like if all of a sudden you were at, you know, like if you created a stateful set, start at 3, give me 3 replicas. So you have 3, 4, 5, 6. And then you go back to an old cluster, you have 3 replicas. It doesn't say start at 3, you have 0, 1, 2, 3. Those are going to be brand new pods. They will have no data. So whatever the application does on initial provisioning is what you get there. You should be able to reclaim your data by scaling it up to like 6 if that's possible. But in any case, you would at least be able to break glass, get your PVCs back, and get your volumes out. The default behavior is going to be a data loss, which is like that tends to leave people inconsolable, right? Like that's just like generally unacceptable. So that you wouldn't get that behavior. So I mean that's why I'm like, this doesn't seem like super risky or super like, I'm not looking at it like this is like crazy. I'm just looking at it like it'd be helpful to have a strong motivation for it. But so that's the feedback I have. But I'm open to, and does anyone else have anything to add or?
Look, we lost you. You're muted.
Hey, guys, if you don't mind, I'd like to move on to the next item in the interest of time. So we have a chance to talk about retriable and non-retriable pod failures for jobs, which is basically a change the semantics of job retries by, I think, Aldo, are you sponsoring this?
Yes.
Like,
Yeah, can you present the README for me, please? So we don't run into the same bug again. I don't know. You replied, but you were muted.
do you want me to present the cap for you? So you
yes, please.
Sure.
Yeah. So in the meantime, I can introduce the cap. As you might know, the job API has the backoff policy currently to control how many retries the pods have before declaring a failure. However, this is not very much configurable in two senses. Let's say if a user knows a particular exit code to consider a pod failed and not recoverable, there is no way to immediately fail the entire job. And on the other hand, there is no way to control when a pod failure is due to infrastructure errors versus the user errors. Infrastructure errors would be things like the node goes down, or the node is preempted, or kube scheduler had to preempt the pod, things like that. You have to click load diff.
It'll do it. Okay, there we go.
Yes, that is very small. Can you go into the stories, please?
The history?
The stories, the user stories.
User stories, okay.
Yes. So that's the context. So we are proposing this API that precisely allows you to determine specialize certain failures by exit code or by failure reason, and to take two decisions: either to completely terminate the job. For example, can you stop there? For example, here we have the rule down there in the YAML. We have the rule terminates when the exit code is not between 40 and 50. So in this case, yeah, the user knows that these exit codes are not recoverable, and then it decides that if there's a failure with these exit codes, the entire job should terminate. If you go to story number 2, there is another YAML, and so the other story, the other rule is based on pod status reasons. This is more useful for infrastructure providers because if somebody's providing a job system, right, for researchers, the administrators don't know what exit codes the application might have. But what we do know is that Kubelet or other controllers insert a certain reason in the pod status to signify why the pod was terminated, or to explain why the pod was terminated. So here we're adding this other rule that, for example, in the case of preemption or no pressure eviction, we can ignore this failure from the backoff limit, so that the user gets more retries. So that's the heart of the proposal. I want to highlight a few risks. One of the risks is precisely these status reasons that are not currently fully documented in Kubernetes. But we want to do a survey of all the reasons that we are currently introducing and document them in the website, and also move all the constants to the core v1 package, so they are more discoverable, and also they are subject to API reviews. And the other somehow risk is that currently the garbage collector removes pods, so there could be scenarios where we lose the status before we can take a decision. But as you might remember, we have already this ongoing feature for counting job failures using finalizers. So once that's completed, this will no longer be an issue. And additionally, there are certain back to reasons. There are certain reasons that are currently, or there are certain components in Kubernetes that currently delete pods and they don't explain why. One of them is kubescheduler, for example. When it preempts a pod, it just deletes the pod. It doesn't say why. So we want to also survey all these usages of pod delete API, and add a reason for it. So we would be adding an option for the delete API, so that we can include a reason that can be added to the pod status. That's pretty much the entire proposal. So I'm hoping to get some feedback. Luckily, I just learned a few minutes ago that the enhancements freeze has been pushed for 1 week, which is great. So hopefully we get to satisfy all the risks met. Our risk mitigations are enough for the reviewers. But yes, I'll open for questions now.
Does it work with cron job, or would you disable this with cron jobs?
No, it would work. Ultimately, it's only about the job failing, and the cron job has its own rules for handling job failures. This is just about the job, but yes, it can be used from cron job.
I started thinking, now that I was listening to who were explaining, whether we should split the reason into separate cap, because that's kind of like one thing of the proposal, and the other one is just the job related changes, and then make depend on the other. That's probably something else. My main question, I already left it in the cap as well, is there any particular reason why you went with slightly complicated API approach towards defining how do you pick which are which exit codes and the reasons and so forth, rather than just reusing something similar to what we have with the label selectors? That probably would give a little bit more flexibility for future growth rather than defining these fields one by one.
Yes, I'm going to answer first the second question. The label selector as it is kind of thought for maps. You know, you have a key and a value, so it doesn't directly translate. But yes, we can tweak the API to look more similar. Ultimately, I think this is more of an implementation detail that we can fix. But yes, I'm working with Michał, who's writing the cap to try to find the closest API to existing label selectors. And so back to your first question, if I'm hearing correctly, you are suggesting we split this in two caps, one just for the delete options and adding reasons, and one for controlling the job for the job failures updates. That sounds reasonable. I guess that would just need extra review. I mean, we're already adding SIG API machinery to the cap as participating, and the reasons change itself is not that big, and it's hard to justify by itself. So kind of I think having it as a single cap provides a bigger picture. But if you disagree, we can split it.
No, that's something that just popped up into my head when I was reading through it. And my primary motivation for a little bit simpler API was that you basically have, similar to the label selectors approach, where you specify what you should be looking at, whether that will be an exit code, the reason field, something else, and then you specify an operator and a bunch of values that you work with. That's why the kind of similar to label selectors approach seemed a little bit more simplistic on the API surface, but it will be also much easier to extend in the future if you decide to add additional operators or additional fields on either side of the of that condition. It's probably something that we can discuss in the cap itself, but that's how I was when I was looking and thinking through what we could implement with a little bit simpler API.
Yeah, it's I guess it's simpler if we can if we are looking at extending it, but it's a little bit more work for the user if you just want to provide min and max, because now you have to define an array of conditions of comparisons, I guess, instead of a single field. Okay, but I'll go back to the, let's say, to the whiteboard to see how we can.
I'm happy to help with that one. But yeah, that could probably be beneficial in the long run. Maybe worth pulling in someone from the API reviewers on that bit as well.
Yes, I added someone from API machinery, Evan, I think. I forgot his last name now. But I try to follow up with other API reviewers if he doesn't respond. Mm, do you see? Do you think the approach of documenting all the reasons seems reasonable?
Definitely, because I'm pretty sure that as soon as we expose this kind of API, a lot of a lot of people will start relying on it. I'm positive that the fact that you will be just implementing this and using this in the job controller will be then used further by other consumers and other controllers who are implementing or working directly with bots in a similar fashion. So that's definitely something that a lot of people will start building on as soon as we expose that value. When it comes to the cap itself, I'm fully supportive of the approach, especially that if I remember correctly, I was one of the authors of the original issues a good couple of years ago when we started initially doing the job controller. It's
More
just
than a
that
couple, I think.
yeah, it was just that we initially decided that we don't want to overcomplicate the API and the controller, but rather gather some additional feedback from the users and only then decide that having those additional options would be reasonable in the long run.
Yes. So just to clarify, I think the feedback that we got from our internal users is that just using the exit code wouldn't be enough when looking from an
That's
administrator
definitely
point
a
of view.
reasonable approach. Having both the reason and the exit code, and maybe potentially something in the future, is one of the reasons that I'm thinking of being able to easily expand the API surface. But rather than having more and more fields added, the fact if we go through the I don't like the comparison, but it's probably the closest. The label selector like mechanism would allow us for a little bit more flexibility when it comes to expanding that surface.
Okay. Yep. That makes sense. We'll fix that. Any other comments?
Okay. All right. Moving on. Paris, you're up.
I think Paris left, but
Yeah, Paris is left.
All right, I'll try to catch her on Slack.
it's definitely a topic that
I'm on a behalf. So.
Yeah, I was partially responsible for that one. So it's definitely something that we want to do in the long run. I I spoke with Paris during KubeCon about it. We did a quick session back in March or April. Um, I just need to find the time to put the right people in the right place, and we will start to putting together a group of interested folks. Paris have a list of all the folks, and we will slowly get this rolling. Like I wrote after the cap freeze, I literally busted currently with all the reviews. But after that is done, I'm happy to pick up the topic because I'm more than interested in growing the reviewer and approver group.
Just to add on that, I have a schedule and folks can take a look at it. And if you want to change something, then you can change or maybe completely change the schedule as of your interest, which matches the app's interest. I will share that in the chat. This is the way we have decided to move on through the process of mentoring if you see like you just want to do any changes, right? You can maybe change the entire document itself. And as of now, we want like 1 to 3 mentors, 3 at max, at least 1. And from the issue mentioned in the mentoring doc of today, like you can see that there are 3 to 5 interested folks already. And if we get this in the mailing list, then maybe we can find more folks, and up to max up to 10 folks we can take on the mentoring stuff.
Yeah, we'll definitely make sure to put something together. Like I said, I'm super interested in having additional reviewers in both the SIG apps and the SIG CLI. So yeah, it will happen. It just requires some time to get it kick off.
Also starting date. For now, it has been decided to end the thing up to the up to 1.25 release. Let's put it up, I guess.
Okay, any other topics? Okay, then I'll give everybody 5 minutes back. Thanks everyone for presenting and for their contributions. And we'll definitely follow up on the mentorship for SIG CLI and SIG apps. Have a good week, everyone.
Thank you.